Okay, the topic we're discussing now is partial fraction decomposition. This is very, very important in Calculus 2. When you take Calculus 2, you need to know partial fraction decomposition. Remember, this subject is pre-calculus. It's the topic you need to know to understand calculus, no? Calculus 1 or Calculus 2. But specifically, this is for Calculus 2. So now, first of all, I want to define what is partial fraction. So what is the definition of partial fraction? Partial fraction. Partial fraction. When I say fraction, it's obvious, something divided by something. But we are talking about, in this case, rational functions. So remember, rational function is division to polynomial. Polynomial in the top, polynomial in the bottom. But you decompose any rational function in different partial fractions. So what is the format for the partial fraction? Well, the polynomial in the top is the degree 0 or 1, no more than. And the polynomial at the bottom is the degree 1 or 2. What means that? For example, to understand clear, suppose you have 3 over x minus 4. Oh, the polynomial, and this is that scenario. Look, this is an area. This is degree 0 because it's just constant. So the exponent of the x is 0 because x to the 0 is 1. And another possibility is, suppose this scenario. This is just example. Don't ask me where come from that. Is degree 1 or degree 2. How do you know? Well, when you factorization the polynomial at the bottom, sometimes you have this kind of irreducible quadratic expression. Okay, you know the factorization and the real field is impossible. So now, but you can factorization in the complex field, but no. In this case, only real. So when you have that situation, you put in the top linear, degree 1. Okay, do you understand the idea? This is the format. This is the presentation. Nice to meet you. What is the partial fraction decomposition? That's it. Suppose we suppose always that the fraction initially is given something divided by something, polynomial divided by polynomial, is proper fraction, proper fraction, yeah. And proper fraction means, sorry, I'm late. Proper fraction means that the degree of the top, the degree 1, let me call it degree 1 and degree 2. Degree of the is proper when the degree of the numerator, the 1, is smaller than degree of the denominator. Otherwise, it's not proper, it's improper fraction. If it's improper fraction, the first thing you should do is long division. So when you are doing long division, therefore, well, suppose that you have P divided by Q, and this is improper fraction, okay? Then you are doing long division. So when you are doing long division, you have a quotient plus remainder over divisor. Yeah, I suppose that part is proper fraction. We focus always in the proper fraction to make the partial fraction decomposition. So in Calculus 2, sometimes the professor, we are doing a special operation in Calculus, no? I don't want to say no the name, but one operation in which you have rational function. And si es proper fraction, you directly go to the partial fraction decomposition. Si es improper, no, you are doing first of all long division, and the quotient part you separate, and there the other part that contains remainder is actually proper fraction, and we break it down in partial fraction decomposition. This is one, okay, this is blah blah blah. However, the most important is to see example, no? To understand this. Okay, this I want to explain the idea behind partial fraction decomposition. I am doing backward. For example, I have two partial fraction, suppose 3 over x plus 4 plus 2 over x minus 3. It's partial fraction, it's another partial fraction. I put together, I condense it, and complete it backward. So the idea I want to explain in a few minutes is decomposition, so break it down. However, I want to explain in opposite direction. No? In opposite direction is the way that we are doing in intermediate algebra. In intermediate algebra, for example, you find the LCD. In this case, the combination x plus 4 times x minus 3, and you condensing these two fractions in only one fraction using the LCD. Okay, and remember, you divide the LCD divided by denominator 1 and multiplication by numerator 1, que es the corresponding, no? When you divide LCD divided by denominator 1, it's obvious that x plus 4 is cancelled. And stay only x minus 3 times 3. Entonces 3 times x minus 3. I suppose you know very well this. This is intermediate algebra. Plus. And when you divide the LCD again by denominator 2 and multiply by corresponding numerator 2, es obvio que you cancel out x minus 3 and x minus 3 and stay x plus 4 times 2. Entonces plus 2 times x plus 4. Well, the rest is elementary. You apply distributive property and combine later. Let's do it. This is 3x plus minus 9 plus 2x plus 4 divided by x plus 4 x minus 3. Okay, lighter. 5x because 3 plus 2 is 5. And negative 9 plus 4 is negative 5. It's negative 1, no? Negative 9. And this is 8. Sorry, 2 times 4 is 8. I make a mistake here. It's negative 1. Okay? Okay, this expression is equivalent to the two fractions separately. However, we condense. The thing we're learning now is different. Is you start from the condensing and you decompose in two fractions or in three, depending on the factor that we have in the bar. So let's do it now. The procedure. Suppose que is giving 5x minus 1 divided by x plus 4 x minus 3. So my goal is decomposition. Okay, of course, when I finish, you get the answer, no? I suppose. Entonces you don't know anything, and you planning to have that situation. Okay, the factors and the denominator is x plus 4 and x minus 3. And you don't know the number here, and you put a letter, AB. The common letter that we're using in this topic is A, B, C, D, something. Okay, entonces now I saw que el least common denominator is x plus 4, x minus 3. And you multiply whole thing by the LCD. When you multiply whole thing by the LCD in the left-hand side, we have only 5x minus 1. because x plus 4 is cancelled and x minus 3 is cancelled. However, in the right hand side, no. In the right hand side, in the first, it's cancelled out x plus 4 and stay x minus 3 plus b x plus 4, something like that. Everyone follow me so far? Okay, one possibility. You say something?
No, you asked if we're following you. I said yes.
Okay, thank you. One possibility to continue is I want to explain two different ways. One way is easy. Another is a little bit more complicated, but not always we can use in the easy, unfortunately. Entonces, in the complicated, when you apply distributing here, it's ax minus 3a plus bx plus 4b, ¿no? Entonces, now we grouping, bueno, the term que contain x, que es this and this, together. Entonces, a plus b, x, because x is common factor, no? And the other is minus 3a plus 4b. And when you compare this binomial, in this case, no? And this binomial, I can see clear, a plus b is fine, look. Because a plus b is the coefficient in front of the x. And minus 3a plus 4b is equal -1. And we have, in that moment, two equations similar to the thing we're doing last class. Therefore, this is an application of the linear system of equation. And well, let's do it. For example, you can use a substitution, or you can use elimination. In this case, in my paper, I'm using substitution because I make a decision, multiplication this equation by multiplication by 3. When you multiply this equation by 3, we have 3a plus 3b equal 15. And this is my equation 1, exactly the same. Ready to elimination, when you add in 1 plus 2, is cancel out that part. This is 7b, and this is 14. Therefore, divided by 7, both sides, b8. And to find a is super easy, because the only thing you should do is substitution, and the easier equation, in my opinion, is the first one. So a plus b is 2 equal 5. Therefore, a is equal 5 minus 2, okay, 3. A is 3, b is 2. Now you replace here. No a anymore, is 3. And no b anymore, is 2. And this is no surprise, because we are doing the problem in different direction. No? At the beginning, I start for this. Here I combine, condense it, you get this answer, right? This is the idea behind partial fraction decomposition. However, we have another fantastic way to do this to avoid the system of equation. So, my opinion is, you using the method where I want to explain now, when it's possible. So when you have a smart value, let me explain what is a smart value. So in this moment, not necessarily apply distributive property, no. You apply smart value. For example, let me try to get x equal 3. Yeah. So use substitution here, x equal 3. 5 times 3 minus 1 is equal, wow, look at that. A is 3 minus 3 is 0. I put intentionally 3 and -4 as the smart value to make 0 one part. This part is 0. Let's go. Plus B 3 plus 4. This is 15 minus 1 is 14. And this is 3 plus 4 is 7. 7B. Therefore B2. Divided by 7 both sides, B2. We get exactly the same answer of this to avoid the system of equation. Sometimes it's impossible. Sometimes in another more complicated example, you need to apply combination of smart value and system of equation. Entonces, if you want to find B, let's do exactly the same, but evaluate at -4. Because I know that when you plug in here -4, we get 0 and B. Entonces 5 times -4 minus 1 is equal 8 times -4 minus 3 plus B, -4 plus 4 que es 0. This is 0. Now let's go on the B part. Entonces we have 20 minus 20 minus 1 is -21 is equal to -7. Entonces -7 is 8 divided by -7 both sides. It's obvious that A is positive 3. And we get exactly the same answer. Any question, guy? Do you understand the idea behind fraction decomposition?
Yes.
Okay. Entonces now, let's move on to the generalize the idea. Not only for the specific problem, no? I understand the specific problem, but in general, what should I do in order to do the partial fraction decomposition? You have polynomial. This is case 1. Case 1. Actually, we have 4 cases, guys. Case 1 is when the Q, so P divided by Q, no? And Q gets the, the denominator is very, very important. Q is formed by non-repeated linear factor. And the word linear indicates degree 1. Okay, when you talk about linear, it's because it's x. Si es x squared, it's quadratic, no? Linear is x1. Entonces now, suppose que when you have P divided by Q, we have something like that. Several factor x minus a1 plus x minus a2 and so on, and a1, a2, a3 is the factors of the Q. X minus a3 and so on. Boom, 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 depending on the degree. And you put ABC, A, B, C, and so on. This is a typical format when it's non-repeated linear. See it repeated, you see another case. But okay, let's practice now. This is another example of the case 1. A little bit more interesting. Suppose x over x squared minus 5x plus 6. Suppose it's given this rational function. Entonces you immediately analyze the degree. Degree of the top is 1. And degree of the bottom is 2. Okay, nice. That means that this is proper. No improper. When it's improper, entonces you should do a long division, but in this case, no long division. Entonces the only thing you should do is factorization 1 by 1, no? Factorization the top is just x, and the bottom, no. The bottom is trinomial. So let's do the factorization trinomial, que is xx, 3 and 2, because 3 times 2 is 6, and 3 plus 2 is 5, and negative, both. Super. We have 2 linear factors. Entonces you separate like that. The first one is x minus 3. Doesn't matter the order, no? And the second is x minus 2. Y I call A and B. It doesn't matter the letter that you're using and the order that we're using. Suppose in your paper you're using B and A. Well, entonces your A is equal to my B. This is no important. This is totally irrelevant. Now LCD. LCD es obvio que es x minus 3 times x minus 2, and you multiply whole thing by the LCD. And the right hand side we have only x equal a x minus 2, que es the opposite, ¿no? Plus b x minus 3. Good. All right, we see. I'm doing well? Yeah. Okay. Okay, now let's using the smart value. Suppose x equal 2. So 2 equal. Part is gone. 2 minus 2 is 0. It's b. 2 minus 3. So 2 is equal negative b. Because 2 minus 3 is negative 1. So b is negative 2. Super easy. You put it here, for example, in the decomposition, you erase this b and you put negative 2 here. Or another way is put 2 here and you put the negative here. It's equivalent, you know? Either way. Now, I'm going to find the a value. Well, you select another smart value que is 3. So 3 over 3, you replace x for 3. Is equal a 3 minus 2 plus b 3 minus 3. If you want that part, you don't need to write because you know that intentionally I did que 3 minus 3 is 0. So the selection of the value x equal 3 is because I know that 3 minus 3 is 0, disappear the b part. So 3 is equal a because 3 minus 2 is 1. Okay, entonces now replace. There you go. And this is the partial fraction decomposition. Do you understand very well or no? Do you understand very well or no? Answer me.
Yes, I understand.
Okay. Let's discuss it now. The case number 2. Okay, the case number 2 is when we have repeated factors. Suppose case 2 is when you have q, denominator always. So p divided by q. So you break it down, factorization q, but q has repeated linear factor. So in that case, suppose to understand more clear, suppose that we have, you have p, it doesn't matter whether the degree, no, it matters, but for the explanation, it's not important who is p. Suppose that q is x minus something, minus 2 to the 4th power. And you see, wow, it's multiplicity 4. This is repeated. Entonces, the format for the partial fraction decomposition is completely different. So you decreasing x minus 2 to the 4th power, x minus 2 to the 3rd power, x minus 2 to the 2nd power, and x minus 2 to the 1 power, que no necesary parentheses. And you put a, b, c, d. A, B, C, and D. This is important thing. Don't forget that. Okay, when you see multiplicity, you copy different partial fraction and you decreasing the exponent one by one. 4, 3, 2, and 1. I bring one example to illustrate this idea. Example. The example say x squared divided by x minus 1 squared x plus 1. Okay, this example is a little bit more complicated because in the bottom of the cube we have combination, different factor, linear factor, pero multiplicity 1 and multiplicity 2. Okay, therefore, the format for the partial fraction decomposition is, for example, you copy x minus 1 squared, you copy x minus 1 to the 1 power, and we have another factor that is multiplicity 1. This is working similar to the case 1, x plus 1. And you copy now ABC. Right? Clear the idea? Our least common denominator is x minus 1 squared, x plus 1. And you multiply everything by this. In the left hand side we have x squared, and the right hand side we have 8 times something, x plus 1, plus b, x minus 1, 1 time, and x plus 1, plus c, x minus 1 squared, something like that. Okay. Now in this case, I suppose we can apply the smart value. A smart value is, for example, 1. Suppose you define x equal 1. Entonces sí, 1 squared es 1. Entonces es 8, 1 plus 1, plus, entonces is 1 minus 1 is 0 and 1 minus 1 is 0. This is gone and this is gone. Super. This is the intention. Now, it's obvious that 1 plus 1 is 2. Therefore, A is 1 half. Okay, A is 1 half. Okay, entonces you substitution here 1 half. You write like that if you want. Some people prefer 1 half. Not necessarily diagonal line, no? 1 half. And some people not. Some people prefer doing that way. Okay, you put 1 and 2 here. Doesn't matter, it's equivalent. I suppose the teacher of calculus preferred that way. Either way. Now let's do it now. Another smart value que es negative 1. X equal negative 1. Entonces ya negative 1 is negative 1 squared, so substitution in this expression is equal. Entonces that part is gone, but that part no. Okay, because negative 1 plus 1 is 0, no? And negative 1 plus 1 is 0. Entonces stay alive only C part is C negative 1 minus 1 squared. Okay, not bad. Entonces es 1, negative 1 squared is 1, and negative 1 is negative 2, and negative 2 squared 4, 4C. Therefore C is 1 quarter, 1 over 4. 1 over 4, 1 over 4, entonces es 1 over 4, 1 over 4. Oh, but unfortunately, we have only 2 smart values. Okay, I have no more smart value. No problems, because we can use another frame value. Of course, frame value is not exactly smart, es el value que create no zero, exactly like smart. But it'll help me because I have information about A and B. I know who is A. Okay, let me copy here. A was 1/2. And B was 1/4. 0 value n 0, x equals 0. So 1 is frame value is easy value. No 100, no 1000, no. 0. 0 squared is 0. Entonces, now 0 plus 1 is 1 and A is 1/2. Plus B, que es 1/4. 0, here 0 minus 1 is -1, 0 plus 1 is 1, entonces es -1, actually, -1 plus C. And 0 minus 1 is -1, square is 1. Exactly, entonces es basically 0 is equal 1/2 minus 1/4 plus C. Therefore, solve for C is super easy. C is equal 1/2. Well, -1/2. I move to the left. Okay, let's do it. -1/2 plus 1/4 equals C. Que es obvio que es -1/4, ¿no? So let me see. Pero this is negative or positive? No, es negative. Okay, this is negative. Bueno, es, you know, by hand. LCD es 4, es -2 plus 1. Es -1/4. Let's see. Let's see, es -1/4. Entonces, C is, you know, erase that C value. Is negative 1/4. Boom. Final answer. You follow me? Yes or no?
Yes.
Yes. Okay, let's move on to the last case, que es more complicated, no? You know, last case complicated always. Case in which you have case 3. The case 3 is when Q, que es el polinomial at the bottom, contain non-repeated, but no linear, sino irreducible quadratic. Irreducible quadratic. Factors. Entonces, one example of this is this example. Suppose 3x minus 5 divided by x cubic minus 1. Well. The degree of the polynomial on the top is 1, linear. The degree of the polynomial on the bottom is 3, cubic. But the first thing you should do is factorization. Well, the top stays the same. It's 3x minus 5. But the bottom, no. The bottom is the famous formula for the difference of cubic is x minus 1, x squared plus x plus 1. Let me recall quickly. Difference of cubic formula is a minus b, a squared plus ab plus b squared. And leave it like that. The reason I leave it like that is because this trinomial is quadratic irreducible. So the solution, si you set out like a quadratic equation equal to 0, is complex. Okay, so basically in this moment I have two factors. The first one is linear and the second one is irreducible quadratic. Okay, now the format for the partial fraction decomposition is, well, the linear is as always, A. And the irreducible quadratic, remember, is Bx plus C. Because this is degree 2 and this is degree 1. And my goal is now find A, B, and C. Okay, let's do it. LCD is x minus 1 times x squared plus x plus 1. When you multiply everything by this, we have 3x minus 5 equal A x squared plus x plus 1 plus B x plus C. Let me copy parentheses, multiplication x minus 1. Super. This is 5. Entonces, in this case, we have only smart value, que es x equal 1. When you create x equal 1, that part is gone. Because 1 minus 1 is 0. So we have here 3 times 1 is 3, minus 5 is equal 8. I'm plugging in 1 squared plus 1 is obvio que es 3, no? 1 squared is 1 plus 1 es 3. Entonces, minus 2 equal 3a divided by 3. Es obvio que a es negative 2/3. You replace, entonces es something like that. Erase a is negative here in the front 2/3. Okay. Now we have no more smart value, only one. Entonces, or you continue using frame value, or you set out the system of equations. I prefer frame value because I select nice. For example, x equals 0. X equals 0, we have negative 5, plugging in here. Plugging in here. Okay, let me erase that part. Okay, plugging in here is negative 5. Is equal a, but I know who is a. A is negative 2/3. 0 plus 0, 1. Okay, it's 1, 2/3. Plus c, because b is 0. B times 0 is 0. C stay only c times negative 1. Okay. Too many negative, multiply whole thing by negative 1. If you want to eliminate the negative sign, entonces 5 is equal to 2/3 plus c. Now c is equal to 5 minus 2/3. Entonces the least common denominator is 3. 3 times 15. 15 minus 2 is 13. 13 over 3. Okay, super. Entonces, C is 13 over 3. How you replace here, professor? Well, I have no idea. Let me try to find B after, and let's see what happens. But at least I copy. C is equal to 13 over 3. Okay. Now, let's move on to another smart value. Okay. I select negative 1 because I consider it easier. It doesn't matter what number you select, guys. Remember, this is a polynomial. Polynomial, the domain is all real number. And you select any value that you consider easier. Suppose case select negative 1. Okay, so negative 1 is negative 3 minus 5 is negative 8, no? Remember, A was 2/3, negative 2/3. parenthesis, and -1 squared +1 minus 1 plus 1. Bueno, es obvio que -1 and +1 is cancelled, but stay alive only 1. Entonces es 1. It's 2/3. That's it. Plus, actually is -1, entonces negative b. Negative b, negative b, negative b. Entonces negative b, a ver, negative b plus c, que I know que c es 13/3. Multiplication, everything by -2, no? Because it's -1 and -1 together is -2. Okay, entonces this is 8, -8, sorry. This is -2/3. This is 2. Remember, this guy is -2. -2, -2, -2. Let me erase. -2. -2. Multiplication by -2. Entonces, to be positive, because negative, positive, minus 13/3 times 2 is 26/3. -26/3. Okay. Okay, now let's solve for b. Is -8 plus 2/3 plus 26/3 is equal to b, no? In this case, least common denominator 3. We have -24 plus 2 plus 26. Well, 26 and 2 is 28, and -24 is 4. 4/3. Equal to b divided by 2 both sides. Es obvio que b is 2/3. Okay, now ready. Ready to see the final answer, no? The final answer is, let me copy here, -2/3x minus 1. This is the first part. But in this case, we have the same denominator que 3, but we have different numerator. So now, I recommend break it down into x squared plus x plus 1, x squared plus x plus 1. And you put here bx. You put here c, right? Who is b? B is 2/3. So now you erase b. No b anymore. No. It's 2 here and 3 down. And c is 13/3. 13/3. Okay, this is the only way. No, you can't use in your imagination, no? But I like that way. Everyone follow me? Do you understand the idea behind this partial fraction decomposition? It's very, very useful. Just in case the professor is teaching calculus too. For sure.
Professor, I have a question.
Go ahead.
Why did you use the friend value and then you used another smart value? Like, does it matter the order or no?
No, the ordering is extremely important. You're using smart first because smart allow me delete one guy. So when you plug in 1 here, magically happen. 1 minus 1 is 0 and that part is gone. So I take advantage of this. The problem is that I have not enough smart. Because I need to use in the frame. Okay? And sometimes happen I have no smart. You see next example, we have no smart. Entonces, I recommend using another idea. Okay? Remember, the last idea is the complicated part, que es set out the system of equation. Do you follow me?
Yes, thank you.
Okay. Let's move on to the case 4, que is the most complicated. I suppose que in the test I never put this. In which you have case 4, que is the last one. We have 4 cases. Q contain a repeated irreducible quadratic. Factors. Suppose this example. Suppose x cubed plus x squared divided by x squared plus 4 squared. Es obvio que denominator x squared plus 4 is irreducible quadratic, so we cannot factorization this expression, the real, and also it's repeated because actually we have x plus 4 times itself, it's a square. So this is the most complicated scenario, no? Okay, just remember the same idea of the repeated. You copy, you copy, you copy, you copy, you copy that exponent 2. And exponent 1. In this case, you put, for example, ax plus b, and this is cx plus d. Okay? Because remember, when there's quadratic and the denominator is linear in the numerator. Well, entonces the LCD is x squared plus 4 squared. And when you multiply everything by the LCD, we have x cubed plus x squared, the denominator is cancelled. Cx plus d is cancelled also. And we have ax plus b multiplication by x squared plus 4. Something like that. Okay? Wow! In this case, we have no smart value because it's complex. Thus, definitely the correct way is using the system of equation. So I foil this. I foil this. I foil is a x cubed, no? Plus 4ax. So multiplication this and this. So inner, outer, first, outer, inner, que es bx squared, and last, que es 4b. Okay. Entonces now we compare immediately that polynomial, the left-hand side polynomial, and the right-hand side polynomial. Y ahí sí que the coefficients in from the x cubed is this, ¿no? Que actually the coefficients here is 1. Entonces sí, A es 1. Es obvio. And B is also 1 by the same reason. Look. Because I saw here x squared is 1. But I have no idea about the rest. So, what about C? What about D? No? I don't know. I have no idea. Okay, no problema, pero I know que CX, look, CX. CX, bueno, CX no. Okay, the rest, que es, okay, try to combine, for example. C plus 4A contain X, here, X and X. And D and 4B no. But when you compare on the left-hand side, we have no that term. That means que C plus 4A is 0. And D plus 4B is 0 also. But unfortunately, I know very well, very well, the A and B, que es 1. Entonces, actually, substitution. C plus 4 and A is 1 equals 0. Therefore, C is -4. And D exactly the same. Plus 4 equals 0 is -4. D is -4. Okay, fantastic. That was easy. Not necessarily smart value, not necessarily. I recommend this method when it is quadratic, irreducible quadratic. Because actually, when it's complex number, we have no smart value. So what is my final answer? My final answer is, this is, let me start for this. A is 1 and B is 1. This is x plus 1 divided by x squared plus 4. And B and C is the same value, is -4. Nice. I recommend putting the negative outside, and you put 4x plus 4 divided by x squared plus 4 squared. Final answer. Beautiful final answer. Any question, guys? Okay, I promise in the review package we practice a little bit more, go over the game to this partial fraction decomposition. And I promise also that you are using in calculus too. Any question? No? Okay, so I want to cover another topic, very, very interesting and very, very easy, que es the systems of nonlinear. Equations. Okay, we studied in detail last class the linear system of equations, and today we study nonlinear. What means to be nonlinear? What means to be nonlinear? Let me explain the idea. For example, you have a system like that. -x minus 7y equal 50. This is my equation number 1. And we have another equation that is x squared plus y squared equal 100. Equation 2. So we have a system que es formed by one first equation que es linear. Remember, linear means that the exponent involved in my equation is 1, linear. And the representation is in 2 dimensions is a line. And this is no, it's quadratic, it's nonlinear. See at least one equation is nonlinear, the system is nonlinear. Okay? Now, see both are nonlinear, of course, it's super nonlinear. Let's see another example. Suppose 2x squared plus y squared equals 17, equation 1. X squared plus 2y squared equals 22, equation 2. And this example, both equations are nonlinear. So obvious that the system is nonlinear system of equation. Okay? Do you understand very well? Okay.
Yes.
Now, how you solve the nonlinear system? Well, there are many ways. The problem is that there are no specific recipe. There are no specific procedure. You're using your common sense and imagination. And the linear is easy because you pair 2 equations and you apply elimination. No. In this case, there are no, depending. There are examples que is much better elimination. There are another example that is much better substitution. But it's the same technique. But you need to be aware that when there's no linear, several weird situations may be happening. Look, let me show you graphically. Well, one fantastic idea for solving nonlinear is doing the graphic in Desmos. Any problem that we are doing, I double checking in Desmos. No? Suppose we have one system, this example, in which one equation is nonlinear, it's a circle maybe, and another is a line. In this case we have two solutions. Look. Two solutions. Excellent. Okay. Suppose another scenario. Suppose que one equation represents like an ellipse like that. And another represents another ellipse like that. Wow. So we have 4 solutions. Look. The common point is the solution. 1, 2, 3, and 4 solutions. We see examples of this. Another scenario is suppose we have a parabola like that. But we have a circle. And this parabola and this circle have no common point, therefore no solution. Okay? So you need to be aware for different possibilities. 2 solutions, 4 solutions, and no solution. We are talking about guy in 2 dimensions. In 3 dimensions is more complicated, but no, 3 dimension no. 2 dimension is this situation. Okay. Let's move on directly to the first example. Okay, example 1. Example 1. Example 1 is minus x minus 7y equals 50. This is my first equation that, by the way, is linear. And my second is x squared plus y squared equals 100, que es obvio, que es nonlinear. We are in front of one system that is nonlinear. As always, we take advantage. When the coefficient is 1 or negative 1, as I see in this equation, the coefficient in front of x is negative 1. You solve this x. So this is, minus x, I copy. Minus 7y equals 50, I copy. I solve for x and minus x is equal 50. 50 plus 7y. But I need no negative x, I need positive x. So you multiply the whole thing by negative 1. X alone is negative 50 minus 7y. And substitution, this expression, in another equation, in the x place here. Boom. Okay, so far we have, well, minus 7, I copy it that way, minus 50 squared plus y squared equal 100. And somehow, I remove one variable, okay, is x. My new equation contains only one variable, que es y. You expand that. Well, okay. Listen to me. This is negative inside the square. You know it's equivalent to say 7y plus 50. Because actually, negative 7 and negative 1 have a common factor, que es negative 1. You know that negative 1 squared is positive 1. So this square magically eliminate the negative sign. Okay, now expand. When you expand this, is, well, let's do it quickly here. 7y plus 50 squared is 49 y squared plus 2 times 7y plus 50 times 50, sorry, is 700y plus 50 squared. is 2500. When you expand this, we have 49 gets squared first, y squared plus multiplication 7, 50 and 2 extra is 700y plus 50 squared is 2500 plus y squared equal 100. Everyone follow me? You need extra explanation? Oh no. Clear or no? Well, clear. So we combine like that. Why not? There are no reason to have separately 49 and 1. Why? 50, 50, 50 y squared plus 700y plus 25 100 minus 100 equal to 0 because I realize que this look like, so we ending in quadratic equation, ¿no? Entonces I put in a standard form, right hand side 0, ¿no? Entonces 50 y squared plus 700 y plus 2400 equal to 0. This is my equation. This is my equation. Okay, of course, this equation is too big. However, as I can see, you can divide by 50. It's possible to divide by 50. If you divide by 50, this equation, divide by 50, this is y squared plus, and 700 divided by 50 is 14, y, and 24 divided by 50 is 48, equals 0. Wow, this is easy. Even by factorization it's possible, because the combination is a and 6, no? A times 6 is 48, and a plus 6 is 14, and plus equals 0. Therefore, y is equal negative 8, and y is equal minus 6. So we have two solutions, I suppose. In order to find, remember, it's the ordered pair x comma y. So in order to find the x value, use substitution in either equation. However, in my opinion, it's easy doing in that way, in this expression, that x is isolated waiting for me. So suppose at y equal minus 8, x is equal negative 50 minus 7 times negative 8. And this is positive 6, no? Because it's negative 50 plus 56 is 6. Entonces, what is the conclusion? The conclusion is the point solution is the point 6 comma negative 8, no? At least for this value. Now, likewise, negative 6, x is equal, same expression, but it's minus 50, minus 7 times minus 6. In this case, negative 50 plus 42, so it's negative 8. And the famous point is the point negative 6, comma, negative 8. Yeah. And we found two solutions. The solution for the system, that system is this and this. Wow. Do you see that? Do you see that? Answer me, yes or no?
Yes.
Okay. Now, as always, I want to double checking in Desmos. Double checking in Desmos. Okay, so I want to share a screen with Desmos. Ew. Do you see Desmos? You see?
Yes.
Look at the example 1. It's a line, it's a circle. X squared plus y squared is a circle. Look, wow, it's big circle. In green color, it's the non-linear part, and the linear part is a line, no? It's the blue line, and the intersection between the green and the blue is the famous point that we found algebraically, -8, -6, and 6, -8. End the story. Do you see that? So always in the test, when in the test you are doing algebraically to show me the word. However, you double checking using decimals to verify that your answer is correct. Okay. Do you see? Yes or no?
Yes.
Yes.
Okay, let's move on to the second example. Example 2 is similar. So one good idea look like that when you have one linear equation and we have one non-linear equation, you apply substitution, and you isolate the variable that contain coefficients 1 or -1. So the same principle that we apply in linear, you apply in non-linear. Substitution. Equation 1, equation 2. Look. So I think, what is the strategy? Well, the strategy is, look, I take the linear equation, gets the number 1. I saw, wow, the coefficient from the y is 1. So I take advantage of this. You solve y is equal to 5 minus 2x. And substitution. This expression here. And the y place. Then we have x squared plus parentheses 5 minus 2x squared equal 50. Super. I focus in this equation. You expand. It's a 25. 25. 25 minus 20. Where come from 20? 20 come from multiplication 5 times 2 and extra 2. Entonces 4 times 5 is 20. Es obvio que es negative because inside the parentheses we have 5 minus. This minus, this is minus. Plus, square this guy, get 4x squared. Minus 50 equal to 0. I move 50 to the left because I suppose that we ending in quadratic. And we combine the term. This 4 and 1 is 5. X squared minus 20, x minus 25, no? Because 25 positive minus 50 negative is 25. Wow, I can see that we can divide by 5 this equation. In order to simplify a little bit, divided by 5 is x squared minus 4x minus 5. Wow, easy equation. Quadratic equation by factorization is pretty easy. The factorization is 5 and 1, no? 5 and 1, 5 times 1 is 5, 5 minus 1 is 4. The signs are negative here and positive. Therefore, one solution is 5 and another solution is negative. Okay, we come back to this substitution that we're using at the beginning. And y is waiting for me. Let's add x equals 5. And then y would be 5 minus 2 times 5. Que es 5 minus 10, que es negative 5. Now the point is the famous point 5, negative 5. Because x is 5, 5, negative 5. Super. And also at x equal -1, y is equal 5 minus 2 times -1. Entonces 5 plus, because double negative become positive, 2 is 7. And the point is the point -1,7. And this is the solution for this system. It's 5, -5 and -1,7. Okay. And immediately, of course, we verify in decimal, no? To make sure everything is okay. Do you follow me? Do you follow me? Yes or no? Answer me.
Yes.
Okay. Now double checking in decimals. Always. There you go. Okay, that was example 1. Now example 2. Look. In example 2, we have another circle and we have a line. And the line and the circle intersecting in the famous solution point is -1,7 and 5,5. No. Good or good?
Good.
Let's move on to another example. Do you see whiteboard, right? Do you see whiteboard? Do you
Yes.
see or no?
Now we do, yes.
Okay, super. This example say, example 3, no? We are doing non-linear system, guys. The first equation is x minus 5 squared plus y squared equal 25. Equation 1, of course, non-linear. And the second equation is weird. It's y equals square root 3 times square root x minus 8. In this example, both equations are non-linear. In this equation, both equations are non-linear. Entonces now, pero I take advantage que y is isolated in the second equation. Entonces hay substitution, bueno, right now, here, here, in the y place. So we have x minus 5 squared plus 3 radical x minus 8 squared equal to 25. Oh, this is easy. Well, actually, we expand that. X squared minus 10x plus 10x plus 25. But this you consider like a monomial, no binomial. So 3 squared 9, parenthesis, x minus 8, minus 25 equal to 0. I'm putting standard because I know we ending in quadratic equation. What do you know that the clue is this? So you have at least one term that contains x squared is quadratic equation. Okay, so now I distribute is x squared minus 10x plus 25 plus 9x minus 72 minus 25 equals 0. All right, yeah. Okay, super. No. Well, I guess secret 25 cancel, no? And we have x squared minus x because negative 10 and positive 9 is negative 1. plus or minus 72, sorry, equals 0. Wow, it's easy equation. It's easy equation. And this equation by factorization is possible also, because the combination is 9 and 8. 9 times 8 is 72, and somehow 9 minus 8 is 1. The sign is negative 9 and positive. One solution is 9, and one solution is negative. Okay, but I need to find the y value. To find the y value, well, substitution obviously in the equation 2. Let's add x equal 9, y is equal 3 times square root 9 minus 8. 9 minus 8 is 1, the square root 1 is 1, therefore y is 3. And the famous point is the point 9, 3. Yeah. Another possibility is x equal negative 8, y is equal 3 times square root negative 8 minus 8, is negative 16. 3 times square root negative 16 is imaginary number. When the situation happens, when in algebra you get imaginary number, it's because do not exist. Do not exist. But the solution is completely wrong. Not wrong, do not exist. So we have only one point solution, que es 9,3. Entonces, in order to understand graphically, geometrically, this idea, I have no idea what's the reason that we have only one solution, not two. Let's verify in Desmos. The algebra is clear, guys? Do you understand the last part? This is classical in algebra. In algebra, when you manipulate, suddenly happen that we have complex or imaginary solution. It's because the solution that you expect to get or you pretend to get to not exist, right? Now let's check, double checking in Desmos. Double checking in Desmos. Okay, do you see?
Yes.
Example 3, look at that. Example 3 is a circle. Wow, it's a circle, and this is the half of parabola. The reason que es a half of parabola is because, suppose, let me copy that. Control C, I want to copy. Let me enter to create one new line and copy and paste. You put a negative here, look, negative. Wow, negative. You have the whole parabola. But the problem is that the function is expressed in explicit form and no specification plus or minus, o sea, only plus. That means that we need only the upper part of the parabola, not the part below the x-axis, no negative, positive. That is the reason that we have one half of parabola and the intersection is only one point, que is the famous point 9,3. Clear? Clear?
Yes.
Okay, super. Let's move into another example. Okay. Another example. This example. Okay, the example number 4, no? Number 4. Number 4 is 2x squared plus y squared equals 17. Equation 1. The other equation is x squared plus 2y squared equal 22. Equation 2. Wow, in this case, both equations are nonlinear. In this case, we cannot apply substitution anymore because you complicate your life because you try to isolate, for example, x, you apply square root. No, in this case, it's much better addition or subtraction, no? So elimination. One fantastic way is the 2, I would like -2 here, you multiply the equation number 2, multiplication by -2. When you multiply the equation number 2 by -2, we have -2x squared minus 4y squared is equal -44. And this is my equation 2, exactly the same, the original equation 2 is equivalent, it's the same thing. When you adding now equation 1 and a new equation 2 together, it's obvious que the parts cancel out. This was the intention. And here we have -3y squared because it's -4 plus 1. And 44, -44 and 17 is 27. But -27. Divided by -3. Y squared is +9. And you apply square root now. This is the moment to apply square root now. Y is equal plus or minus 3. So we have two values of the y. Thus in this case we expect, maybe 2 or 4 solutions. Let me see. So now in order to find, for example, suppose at y equal +3. And substitution where? In either equation, I don't know why I select this equation. This one. Because in my mind it's easier. Entonces, x squared plus 2 and 3, no? And 3 squared equal 22. Oh, look at that. You can substitution both if you want. Because, look, let me show you. So you substitution y equal plus or minus 3. You have plus or minus 3 here. And plus or minus 3 squared become positive. So actually we have x squared plus 18, no? 3 squared 9 and 2 is 18 equal 22. So x squared is equal 22 minus 18 is 4. Apply square root both sides. X is equal plus or minus 2. Entonces, what is the interpretation there? Well, the interpretation is that actually we have 4 points. The 4 point is a combination, no? Everything together, right? Is 1, 2, 3, and 4 points. Suppose que I select 3, 3, and -3, and -3. No, sorry, this is a x value. Mistake. The x value is 2, 2, -2, -2. And the y value is 3, -3, 3, -3. Okay? It doesn't matter the order, there's your solution set. But we have 4-point solution in this exam. The idea is clear or confused? The idea is clear or confused?
Clear.
Let me check in to make sure. Let me check in my Desmos. Okay, everything is okay. 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 I suppose que you see Desmos now. Yes or no? Look. Wow. It's 2 ellipses. the orange elixir, the purple color elixir, and the intersection is 4 point. It's the famous 2, 3, 2, minus 3, minus 2, minus 3, and minus 2, positive 3. Do you see? This is the beauty of that, guys. Okay, we can check it always. Always. Okay, one more example, and that's it. Do you see now the whiteboard?
Yes.
Okay, the last example. The last example is easy. Is x squared. This is example 5, no? X squared plus 4y squared equal 4. Equation 1, nonlinear. X squared minus y squared equal 9, no? It's 9? Yeah, it's 9. Also nonlinear, two nonlinear equations. Remember, when you have two nonlinear equations, never substitution. Maybe elimination. Well, okay, take advantage. Okay, one is positive, one is negative, and you multiply the equation number 2 by 4. Multiplication by 4, no? By positive 4. Then we have 4x squared minus 4y squared equals 36. And this is a new equation 2 after the multiplication. And one more time, using the combination this and this. You are adding equation 1 plus equation 2 new is 5. This and this, this and this, sorry, cancel. And now is 40 because it's 36 plus 4, 40. Okay, now divided by 5. X squared equal 8. Apply square root both sides. X is equal plus and minus. A, you know, A is 4 and 2. And when you apply square root 8, is square root 4 get 2. 2 radical 2. Super. Now we're using, for example, in the equation 2, original 2, is easier in my opinion. And you substitution both, because when you substitution plus and minus 2 radical 2 a square here in that equation, look. Minus y squared equal 9. That's my goal is solve for y, no? And this is 8. It's so big, it's 8. 2 radical 2 squared is 8. It's exactly the same power. Minus y squared equal 9. Okay, entonces minus y squared is equal 9 minus 8 and 1. Minus y squared is equal 1. Therefore, y squared is equal negative 1. And when you apply square root, again, we have imaginary number. And when you have imaginary number, it's because to not exist this solution. So what do you suppose? You get that x equals something, but y do not exist. The solution is the point, x comma y. See, at least one failed, no solution. No solution we have in this example. Wow, but why? I don't understand why. Let me check in decimals to make sure okay, this makes sense or not. Do you understand the algebra?
Yes.
Yeah, okay. Let's move on to decimals. example 5. Look at the example 5. 5 is two nonlinear equations. Boom. The problem is that one equation gets the purple color is ellipse, and another equation gets the black color is hyperbola, and this curve never touching. That is the reason that we have no solution. Super good? Super clear?
Yes, it's clear.
Okay, guys. Entonces, it's enough for today. Remember, I posted the new homework for the test number 4 and the test number 4 on online Alex, no? Mm-hmm. Okay, any question you have? Everything's clear? Or no?
Yes, everything's clear.
Okay, super. Okay, so we finish. Have a nice day, guys. Bye.
Bye. You have a good day, Professor.